Okay, we've retained another integral. This one's from the MIT Integration Bee 2006, problem 14. We've got the integral from 0 to infinity of 1 over x plus square root 1 plus x squared all squared dx. Okay, I just did this one recently with a different method, and today from the comments what I got from Adandap was that we could do this using hyperbolic trig substitution. So what we want to do is we want to substitute, just noticing what we have here, 1 plus x squared. What's going to work nice for a substitution is going to be x equal to sinh of t. We can take a derivative, and so for our dx value, this is just going to become cos t dt. And before I substitute, what I'm going to do is set up, let's just write this sinh t in terms of the definition. So this is going to be the same thing as e to the t minus e minus t all over 2. So now we'll just go ahead and substitute over here. So first we need to evaluate infinity. So we're saying if our x value is going to be infinity, that's going to happen if t is equal to infinity. Because you notice if t is equal to infinity, this piece right here is going to infinity, and this part here is going to 0. So that's going to work. So I'll update this bound to infinity. Then evaluating at 0, we're saying x is going to be 0. That's going to happen when e to the t is equal to e to the minus t. You'll notice that works when this term is equal to 0. Sorry, I mean to say that this is when t equals to 0, because when t is 0, this is 1. But this term here is also 1, and then we get 0 in the numerator, so t equals 0 is going to work there. Now for our dx value, we'll just write in this cos t dt. Then x is going to be sinh of t. Then let's just focus on this part and try to simplify it before I plug it back in. So we have sinh t is our x, so I can write this as 1 plus sinh squared of t. But we have the identity that this is the same thing as cos squared of t, so I can write this as square root cos squared of t. Square term inside the square root, we can write it as absolute value cos of t, but cos is always positive, so I'm just going to drop the absolute value, write this in here as just cos of t, and this is all going to be squared. But then we can simplify this further. We just need the definition for cos of t. You may know this identity already, but let's just make it clear. So for cos of t, really similar to this, it's going to be e to the t plus e minus t all over 2. So if I had sinh to cos using these definitions here, we have the common denominator of 2. So I'll write it all over 2. We end up with e to the t minus e minus t for sinh. And then for cos, e to the t plus e minus t. But then these terms are going to cancel because we're subtracting there. And so we end up with 2 e to the t over 2. 2's cancel, and so this right here is just e to the t. So now I'll go ahead and rewrite this, but what I'm going to do is I'm going to put everything in terms of the definition. I'm going to put everything in terms of exponential, and we'll have no more, and I'll remove all the sinh and cos terms. So what's going to happen is for cos t, we'll use this. We'll write it as e to the t plus e minus t, but for this 2, we'll bring it out front as a 1/2. And then here we're going to have e to the t squared. I can write that as e to the 2t dt. But now let's just divide this into the numerator and split it into 2 integrals. So we have this going from 0 to infinity. For the first one, we're going to have just e minus t dt distributed in the 1/2. So for the second integral, again, going from 0 to infinity, this is going to become e to the minus 3t dt. But now we have 2 easy integrals. Actually, I should just leave the half out front for now. So we'll do it like that. We'll factor out I just multiplied it in, but now we'll factor it out. So whatever. Now integrating e to the minus t, that's going to be minus e minus t. Then integral here, this is going to be minus e minus 3t over 3. And we just need to evaluate from 0 to infinity. So now we can just go ahead and evaluate. But notice at infinity, because these are exponentials with negative exponents, everything here is going to 0. So this first term is just going to be 0. Then for the second part, we're going to have minus 1/2. And then we plug a 0 into this first piece, we're going to have a minus 1. And then plug a 0 in here, we're going to have minus 1 over 3. Distributing in the minus sign, everything becomes a plus. This becomes 4/3. So just multiplying 1/2 times 4/3. For my final solution of this, we just get 2 over 3. Okay, there you have it. Good problem from MIT 2006. Thanks everyone for watching. Have a good day.